Okay, so grade 11s, grade 10s. Let's just quickly recap what we have done for those that are at home. We've started looking at connective tissue. Okay, so connective tissue. This is on page, what of your textbook? Page 1.36, 37 to 38. Okay, so 1.36 to 3.8. Or 1.38, whatever. Okay, we've done the four first types of connective tissue. So the first one we did was called areolar connective tissue. Okay, so areolar connective. Areolar connective tissue is found basically surrounding organs and between our skin and our layer of our muscles, etc. So it's a very commonly found connective tissue. The thing about connective tissue is they must have three things. What are those three things, grade 10? They must have a matrix, A, the cells and fibers. Okay? So what is the matrix again? This is a ground substance. And that matrix can either become a little bit more fluid or it can become a little bit more solid depending on the function. So if it's bone tissue, for example, it'll be more solid to actually give it that strength. If it is blood, for example, it's going to be a bit more fluid. So depending on the type of connective tissue, the matrix will change, and then we must have cells and we must have fibers. So in our areolar connective tissue, okay, if we just quickly draw our areolar connective tissue, we've got two types of fibers. We have white inelastic fibers. Those white inelastic fibers give you strength, and they usually run parallel to each other, and then they almost make like a grid to give you that strength. Then we have elastic fibers. These are yellow elastic fibers. And yellow elastic fibers are more kind of branched, and they give obviously a little bit of elasticity. So your white fibers are for strength, while your yellow elastic fibers give you flexibility. And then in amongst this tissue, you'll have different types of cells. Okay? And so you guys can have a look at that in your textbook, the various types of cells and what they do. So there's a number of cells. For example, you would have macrophages. Those basically have an immune response. They're part of your immune system. And they engulf anything that's a foreign body. Okay, so macrophages. We would have these ones over here are called fibroblasts. Fibroblasts make new fibers. Okay, and then we have a whole bunch of other ones like leukocytes or mast cells. So we'd have mast cells, they have an immune reaction, and we have leukocytes. Both of these provide immunity. Okay, so that's areolar connective tissue. Happy, everybody? Yes? Okay, the next type of connective tissue we did was dense connective. Okay, dense connective is divided into two types. We have tendons and ligaments. Now this particular group, dense connective tissue, they have more fibers than cells and the matrix. So their matrix is very small, not very many cells, they have more fibers. So tendons are made up of predominantly white inelastic fibers, while ligaments are made up of predominantly yellow elastic fibers. Okay, so we have tendons and we have ligaments, white connective tissue, so it's very strong connective tissue, and we have yellow elastic connective tissue. All right, what do tendons do again? Grade 10s? What do tendons do? They connect muscles to bone. What do ligaments do? Connect bone to bone. Okay, so very quickly for those at home, I just used, where's my elastic? Oh, here. Okay, so white fibers, the white fibers are strong, giving it that strength. They hold it nice and tight. That's attaching your muscle to your bone, not giving it any movement. While ligaments are elastic, yellow elastic fibers, giving it the ability to flex, which is why we're able to move our joints. Okay. Then the next one we did very quickly was our, talk to me, cartilage. Cartilage, like the pin over ear, tip of your nose, vertebra, etc. Okay? Cartilage has got a matrix, a specialized matrix that is a little bit more solid. Okay, so the matrix is solid and it's got a specialized name called chondrin. Okay, so the chondrin is a little bit more solid in nature, and that's going to hold the shape of the ear, shape of the rings of the cartilage, whatever it is. And in the cartilage we have pockets of more fluid kind of areas that contain cells. So those pockets of more fluid parts are called the lacuna. Okay? The lacuna is a little bit more fluid. Okay? And the fluid parts contain the cells. What are the names of the cells again, grade 10s? Chondrocytes. And chondrocytes always occur in groups of 1, 2, or 4. Okay? So they can occur singularly, they can occur in pairs, 2 or 4. And so these cells are called chondrocytes. Okay? So we have chondrin is the matrix, a bit more fluid. We've got these areas that are pockets with, the chondrin is a bit more solid, apologies. The lacuna is a little bit more fluid, and that has these pockets of cells called chondrocytes. The chondrocytes will make new matrix when we need to, and then surrounding this is a membrane which would be called the perichondrium. Perichondrium. And so you can see with cartilage, the word that is associated is this chondrin. Can you see it? Chondrin, chondrocytes, perichondrium. Are we all happy with the 1, 2, 3, 4 types of connective tissue we've done so far? Fantastic. The next one is bone. And bone gets slightly more complicated than what we've seen before. Okay? So bone tissue is actually made up of a system called the Harversian system. So the Harversian system was discovered by a guy whose surname started with, I think it's somebody Hayes, and that's why he called it the Harversian system. Okay, I can't remember his name. Doesn't matter. So we need to study the Harversian system to understand what that system looks like. And then these systems lie next to each other. So if you have a look in your textbook, we don't have any power today. You see this picture over here? Yes? We're going to look at one of those. Now that you need to draw with me, please. You need to draw with me, and you need to label with me. Okay, grade 10? Yes? So the connective tissue you're doing is bone. Bone. Okay, so bone. Bone is made up of a Harversian system. I'm going to write it on the board. Harversian systems. Okay, sometimes called an osteon. You see that word osteon in your textbooks or in something that you're reading. If you do, biology reading, life sciences reading for fun, like some of us do. Then if you see osteon, you know what I'm talking about. Joke, some of you guys don't read. Okay. Right, the Harversian system has, in the center of your Harversian system, you have a Harversian canal. Oh, squeaky pen. Okay, so there's a Harversian Haversian canal. And surrounding each of these Haversian canals is layers of concentric crystallized matrix. So surrounding this is layers, and these layers are called the lamella. Just want to do one more. So each one of these has got crystallized matrix, which is called the, give my pen a bit of a shake, lamella. And lamella have got crystallized matrix. And that crystallized matrix is very, very, very solid. It's very strong. Okay, and it's crystallized with calcium carbonate. Calcium carbonate, and calcium phosphate. Is calcium phosphate? Yes? Can't see. Okay. Calcium carbonate basically allows this crystallization of our matrix. So you've got these rings, concentric rings of crystallized matrix. Any questions yet? Yes? Are we all happy? Let's just make this ring nicer. Okay, in the center we have this Haversian canal. Everyone happy? Okay. That Haversian canal, let's label it. Has got 4 things in it. Canal. That Haversian canal has got 4 things in it. It'll have 2 blood vessels. It has blood vessels. It'll have nerves. And it has lymph vessel. It'll have a lymph vessel. So it has two blood vessels, okay, or capillary network. So this is going to be an artery and a vein, okay. So we have an artery and a vein, we've got some nerves, and we've got a lymph vessel. Are we all happy with that? Yes? Okay. So these concentric rings are called the lamella. Along the lamella, we have pockets of uncrystallized matrix. So we have these kind of areas where we have uncrystallized matrix. You all cool with that? That area that has the uncrystallized matrix in it is called the lacuna. Just like we saw in our cartilage, we have lacuna. Inside your lacuna, you would have bone cells. So there are bone cells. Bone cells inside of our lacuna. And those bone cells are called osteocytes. Osteocytes. Osteo means bone, cytes means cells. So what cells are these? These are bone cells. And then these pockets of lacuna, this is filled with uncrystallized matrix. So we have these pockets of uncrystallized matrix that hold the cells, the bones. Bone cells are called osteocytes. Okay. Any questions so far, grade 10? Okay, then there's one more structure connecting our lacuna. Are these little channels or canals of uncrystallized matrix. So these areas where we have connections happening here of uncrystallized matrix. It's almost like little channels connecting them all, so that we can build new cells, and these cells can move from one area to the next through this uncrystallized matrix. So these little canals of uncrystallized matrix have a really cool name. I'm going to write it in red because my blue pen's dying as well. So once again, this is uncrystallized. Yes. Getting how to spell crystallized. Uncrystallized canals, almost. So uncrystallized matrix with canals, and their name is canaliculi. C-A-N, can, and aliculi. Can, is it C-A-N-I? I always forget canaliculi. A-L-I-C-U-L-I. Canaliculi. This is an A, not an A. Canaliculi. Canaliculi. Okay? So there's quite a lot of new words, big words here. So I wanted to do a video because it's quite complex. Are we all happy so far? So this is the structure of a Haversian system. A Haversian system has a central Haversian canal. In the Haversian canal, we have blood vessels, arteries and veins, nerves, and lymph vessels. Surrounding your Haversian canal is crystallized matrix rings, these rings of crystallized matrix called lamella. These are crystallized with calcium carbonate. That makes your matrix very, very strong. So it's a strong, solid matrix, so crystallized matrix. And between these crystallized matrix are these pockets of uncrystallized matrix. Oh, where's my pockets of uncrystallized? There. A lacuna, uncrystallized matrix. These little lacuna contain the bone cells called osteocytes. Okay? And then we have connecting our lacuna together with these little channels of uncrystallized matrix is these things called canaliculi. Canaliculi. Okay, so I'm going to show you a model of this. Okay? So this is a model that I made a couple of years ago, quite a while ago, when I first started teaching. So this is a model of a Haversian system. So in our Haversian system, we have this central Haversian canal. Can you see it there? The central Haversian canal contains red for an artery, blue for a vein, white for a nerve, and yellow for a lymph vessel. So there are 4 things that are found inside of this Haversian canal. Yes? Then surrounding this Haversian canal, just like we see the rings of a tree, okay, is these concentric rings of lamella. Okay, these hardened, strong lamella. Okay, so these concentric rings are crystallized matrix, making it very strong. And then you have pockets over here, these little lacuna. You see that? So the lacuna are uncrystallized matrix, and then connecting our lacuna are canaliculi. And that whole thing is our Haversian system. Then bone tissue. So if there was one there, there'd be another one there, another one. All of these Haversian systems making up our bone. So bone is actually, and this is microscopic, okay? It's a microscopic structure. You won't be able to see it. Is this Haversian canal. Okay. Any questions with bone? Gets a bit complicated. Okay, let's check we've got everything from our textbook. So we're on page 137. Bone, obviously, it's a part of our endoskeleton of vertebrates. We have these Haversian canals with blood vessels, nerves, lymphatic vessels done. Around the canals, we have these concentric layers of lamella. The lamella have fluid-filled spaces called lacuna. The lacuna have our osteocytes in. Connecting our lacuna is our canaliculi. And then surrounding that is the periosteum. Okay, I don't worry too much about the periosteum because it's not quite at this specific location. Because all of these Haversian canals are going to be connected, and then that will be surrounded by a periosteum. Okay, functions of bone, obviously, guys, gives us shape, structure, and provides for locomotion. Attachment of our muscles and brings about locomotion. Storage of storage of minerals like calcium carbonate. Okay, any questions, grade 10s? Are we happy? Cool, that's it for today.